So good day. In today's lesson, we're considering sequence and series. Sequence and series. So when we say sequence, what do we actually mean by sequence? A sequence is just a list of numbers. A list of numbers. Or you can put a pattern. Just like we learned in primary school, if I put some numbers like this, if I say 4, 7, 10, in primary school or basic school, we can feel this. So if this is 4, this is 4, this is 7, this is 10. So you notice that for me to move from 4 to 7, it's like I added 3. 7 to 10, I added 3. So adding 3 to 10 will give me 13. Then adding 3 to 13, we have 16. So this is a pattern. So forms a sequence. So in a sequence, we have what we call a pattern. So in this case, the pattern is formed by keeping adding 3. So that's the sequence. So there are some different type of sequence. So we have some that you keep adding a number. There are some that you may need to decrease the number. Take for example, if I have something like this, 95, 90, 85. So if you look at this pattern, so in this pattern, it's like I'm reducing the terms by 5. So the next term here will be like 80. So that's 95 minus 5 we give 90. 90 minus 5 we give 80. So 80 minus 85 will give us 75. So in this number pattern, we keep subtracting 5. We keep subtracting 5. Then we have some other pattern in which let's say I have 4, 8, 16. If you look at this number pattern or this sequence, you will notice that it's like we keep multiplying by 2. So 4 times 2 we give 8. 8 times 2 we give 16. So that means 16 times 2, that will give 32. Then 32 times 2, that will give 64. So in this pattern, we keep multiplying by 2. We keep multiplying by 2. So we can have another pattern. Let's say I have something like let's say I have 100, I have 50, I have 25. So we have this. So if I look at this pattern, the first one is 100, the next one is 50, the next one is 25. So we have to guess this. So it's like what? So good. It's like I divided by 2. So 100 divided by 2 will give us 50. 50 divided by 2 will give us 25. So when I divide 25 by 2, that will give us 12 and a half. That is 12.5. So if I divide 12.5 by 2, that will give us 6.25. So in this number pattern, we can say we are dividing by 2, or we simply say we are multiplying by half. We are multiplying by half. So same thing as saying we are dividing by 2. So we have other types of sequence that we are going to that we have other types of sequences, but we only restrict ourselves to 2 types now. So those are the 2 types I've discussed here, and those 2 types are: the first one, we call the first type, we call it the arithmetic sequence. Or we can also call it linear sequence. So arithmetic sequence, or you can call it linear sequence. Arithmetic sequence or linear sequence. So in arithmetic sequence or linear sequence, so the first 2 examples I gave here describe a linear sequence. So in the first one, we keep adding 3. So in a linear sequence, we keep adding a number. So it could be a positive number, it could be a negative number. So in the first one, we keep adding 3, so which is a positive number. In the second one, we keep subtracting 5, or we keep adding -5, which is a negative number. So that is when you have a sequence in which you keep adding a number, either a positive number or a negative number, we call that sequence a linear or arithmetic sequence. Then the second one is geometric sequence, which is the last two, which describes the two last examples I gave. So this is geometric sequence. Geometric sequence. So in a geometric sequence, or you can also call it exponential sequence. So in a geometric or exponential sequence, in a geometric or exponential sequence, we keep in a geometric or exponential sequence, from what I did there, we keep multiplying by a number. So the first example here, the third example now, I keep multiplying by 2. Then the last example, I keep multiplying by half. So that is a geometric sequence or an exponential sequence. So we will be discussing two types of sequences here: arithmetic sequence or linear sequence, and geometric sequence or exponential sequence. So don't forget, in arithmetic sequence, we keep adding a number. It could be a positive number or a negative number. But in a geometric sequence, we keep multiplying by a number. So we look at arithmetic sequence now. So as we discussed earlier, we have arithmetic sequence, so our linear sequence. So in our arithmetic sequence, we say that we keep adding a number, or we keep subtracting, and we keep adding a number, either a positive or a negative number. Take for example, if I have a sequence like this, so let's check if this sequence is arithmetic. So is this sequence arithmetic? Let's see. The first one here, for me to move to this, we added 5 to 5 to give us 10. We added 5 to 15 to give us 10 too. So since we keep adding a number, then it means an arithmetic sequence. So that means the next time will be 20. The next one will be 25. Do you get that? Now let's look at another example. We want to see if this is an arithmetic sequence. Let's see. 7 to 16 will give me, that is plus 9. 16 to 26 will give plus 10. You can see that what we added is different, so that means it's not an arithmetic sequence. So this is not an arithmetic sequence or arithmetic progression, AP. So AP, arithmetic progression. So that's what I'll be using most now, arithmetic progression. So but it's not an arithmetic progression, but I can get the next term. So if for me to get the second term, I added 9 to the first term, and to get the third term, I added 10 to the second term. So that means to get the next one, I'm going to add 11. Good. So we're adding 11. So that will give us what? 37. Then that means the next one, I'll add what? 12. Good. That's correct. So that will give us what? 49. But this is not an arithmetic sequence. So this is not part of what we'll be discussing. So I just gave that as an example. So to identify an arithmetic sequence, you must make sure that what you are adding is constant, either a positive or a negative number. Do you understand that? Now let me give another example for arithmetic sequence now. So look at this example. We have 72, 64, 56. Let's check if it's an arithmetic sequence or arithmetic progression. 72 to 64. So that's like we subtracted 8. Then 64 to 56, that's like we subtracted 8 as well. So since we keep subtracting it, that makes it what? An AP. So this is an AP, arithmetic progression, or simply put, an arithmetic sequence. So what do you think the next term will be? So how do we get the next term? We also subtract 8 from 56. So if we subtract 8 from 56, that will give us what? That will give us 48, right? Good. Then the next one will give us what? 40. Do you get that? So if it's an arithmetic sequence, the term we keep adding, we call it a name. So the term we keep adding, we call it common difference D. What did I say? Common difference D. So the term we keep adding, either the positive number term we keep adding or the negative term we keep adding, we call it common difference D. So we use letter D to denote that. So that number we keep adding or we keep subtracting is what we call the common difference D. So for example, now this first one, now I keep adding 5, so which means my common difference here is what? Is plus 5, or you say 5. Then for this one we keep adding minus 8, so that means the common difference here is what? Minus 8. So the number you keep adding, or the number you keep adding, either the positive or the negative number that you keep adding, is what we call the common difference of the arithmetic sequence or progression. So there are some other symbols that we use under sequence. We have what we call the first term of the sequence. So the first term of sequence is denoted as A. So we use A to denote the first term of a sequence. A to denote the first term, D to denote the common difference. Then we also have another symbol we use. We have what we call N. So N is the number of terms. The number of terms you have. The number of terms you have in this sequence. So D for the common difference, which is the number that we keep adding, either the positive or the negative number. A is the first term, then N is the number of terms. Now, if we have our terms like this, now each term here, the position of each term we give it in, like 5 here is the first term, which is A. So 5 here is the first term, which is A. Then 10 is the second term, so we can call that T2. So T1 is the first term, so that is for the first sequence. Now that is 5, which is also A. So T1 is the first term, and that is A as well. Then T2, which is the second term, is 10. Then T3, which is the third term, is 15. So, and we can continue like that. Do you get that? So for the second sequence now, so can you answer that now? So what is the first term here now? In the second sequence, we have what? 72. Good. What is the second term? That is 64. Good. What's the third term? That is 56. So do you get that? So that is for an arithmetic sequence. Now the question now is, what if I want to find the 100th term of a sequence? I want to find the 100th term. I know the first term, I know the second term, I know the third term. Now to find the 100th term, do I have to keep listing the term till I get to the 100th term? Well, you can do that, but that will take a lot of time, since we only need the 100th term. So we have a short way of doing that, and that is what leads us to the next thing we are going to look at, which is what we call the nth term of sequence of an arithmetic progression. Nth term of an arithmetic progression. Now, if you want to find, just like I said, the 100th term, we have our sequence here. Let me use the first one: 5, 10, 15. If I want to find the 100th term here, the terms continue. So already we said that what we have D, which is the common difference. So let me just use an acronym here, DAN. So for every sequence you are dealing with, don't forget the DAN. D here is the common difference. So D here is what? For this, we keep adding 5, right? So that means our D here is 5. The first term is what? Is 5 as well. This is the first term, which is 5. Then N here is the number of terms, depending on what you are looking for. Now for this question, I want to find the 100th term. I want to find the 100th term. So just like I said, we don't need to list all the terms before we can get the 100th term. So to get the nth term of an AP, we have an expression for that. So I will not go into the details of that. So I'll just give the expression. So the nth term of an AP, if you want to find the nth term of an AP, it is simply the first term plus n minus 1 multiplied by the common difference. Just take note of this formula. I don't want to go into the details of how we arrive at this. So if we want to find the nth term of an AP, we use this expression. So for example, now if I want to find the 100th term, so that means I'm looking for T100. So if I'm looking for T100, that means my n here will now be what? Will be 100. So T100 here will be A. What is the first term of this? That will be 5 plus n is 100. So 100 minus 1. Then I'm multiplying this by 5. So when we open this bracket, we have 5 times, 5 plus 99 times 5. So this will give me 5 plus 495. So which will give us 500. So that is the 100th term. Without having to without listing all the terms, we have obtained the 100th term. So we can use this expression to find the nth term of an AP. So the nth term of an AP is A plus n minus 1 times Z, where A is the first term, n is the number of terms, D is the common difference, then Tn is the nth term of what we are looking for. So do you get that? So as we have said, the nth term of an AP is given as this expression now. Tn is A plus n minus 1 times D. A is the first term, n is the number of terms, then D is the common difference. So we have a question here. Find the nth term of the AP. 19, 12, 5. Now let's first establish that this is an AP. So let's see if this is an AP. Remember, for an AP, we keep adding a number, that a positive number or a negative number. So 19 to 12. So 19 to 12 is like I subtracted 7. Then 12 to 5 is like I subtracted 7 as well. So that means it's an AP. So from there we write our DAN. D A N. So our D here is the common difference, which is minus 7. Then our first term here is 19. So the n here we want to find is the nth term. So we don't know the n. So we write our formula for the expression of the nth term. The nth term is given as A plus n minus 1 multiplied by D. So since the n is not specified here, so we just keep the n as n. So this will still remain as Tn since it was not specified. They only said nth term. So A is what? 19 plus n minus 1 multiplied by minus 7. So if we should simplify this, now we have 19. So plus n times minus 7 will give us minus 7n. Then plus times minus 1 times minus 7 will give us plus 7. So if we should simplify this, we are going to have collect like times 19 plus 7 will give 26 minus 7n. So this is the nth term of the expression. So knowing this nth term now, we can use it to find any other term. I believe you understand. So we have another question here. The question says find how many terms are in the AP, minus 8, minus 2, 4, then dot dot dot. So that means there are terms in between 142. So we have this. So remember, let's write out our done. So D here is the common difference. So let's see the common difference here. From minus 8 to minus 2. That should be like what? So let me write it out. Minus 2, which is the second term, minus 8. So that will give us 6. So that means we added 6. Let's check the second one. 4 minus 2. So this will give us 6 as well. So that means our common difference is plus 6. So this is the last term. So this is our Tn. So we don't know the number of terms. So that's what they say we should find. So how many terms? So we don't know the number of terms. So that'll be our Tn. So our Tn is 142. So the common difference, the number we keep adding, is positive 6. So that is 6. Our first term here is minus 8. So we don't know what n is. So we write the expression for our Tn. Tn is a plus n minus 1 multiplied by d. So Tn has been given already. So this is 142 equals minus 8, then plus n minus 1 multiplied by d. Our d here is 6. So multiply by 6. So we can simplify this. Collect your like terms now. So if I collect like terms, I have 142 plus 8 equals 6 multiplied by n minus 1. So this will give me 150 equals 6 multiplied by n minus 1. So I can divide both sides by 6. So if I divide both sides by 6, I have n minus 1 equals to 150 over 6 will give us 25. So taking 1 to the other side, we have 26. So that means there are 26 terms in this sequence. So there are 26 terms in this sequence. So we have that. So I believe we understand that. So in the next video, I will continue with arithmetic progression. Thank you.